Welcome to the second video of linear programming, where we show how to solve the cookie problem.
Yes, most of you probably don't remember the cookie problem from last video. I don't even remember the cookie problem. How about you, Jordan?
Nope.
Let's roll that clip. Abby and Bing Wu own a bakery shop that specializes in cookies. They make plain cookies and they make ice cookies. 1 dozen of their plain cookies requires a pound of cookie dough and no icing, while 1 dozen of their ice cookies requires 0.7 pounds of cookie dough and 0.4 pounds of icing. They know that no matter how many cookies they make, they'll sell them all. Now, their decision to make how much is limited by the following things. They have room in their oven to make 140 dozen cookies for tomorrow. They have 110 pounds of cookie dough and 32 pounds of icing. And they have 15 hours of preparation time to make the cookies. Now, the ice cookies takes 0.15 hours of preparation time, and the plain cookies takes 0.1 hours of preparation time. They sell their plain cookies for $6, and it costs $4.50 to make, and their ice cookies sell for $7, and it costs them $5 to make. They want to know how many cookies to make to get the maximum profit.
Let's set up our variables and objective function. Keep in mind with the best possible profit, so the numbers that deal with profit will be our objective function.
That came out very clear, Jordan. Nice job. First, we need to define our variables. We'll have 1 dozen plain cookies equal X. And we'll have 1 dozen ice cookies equal Y. Revenue is the amount of money that the bakery shop is taking in. For plain cookies, which is X, that's $6. Now for ice cookies, which is Y, that's $7. Cost is the money it takes to make the cookies. For plain cookies, it costs them $4.50 per dozen. And for ice cookies, it costs them $5 per dozen. Now we get on to profit, which equals the revenue minus the cost. For plain cookies, that's $6 minus $4.50 to give you a $1.50 profit. For cookies with icing, that's a $7 revenue minus a $5 cost to give you a $2 profit. Now we move on to our objective function, which is the function that we want to optimize, which would be optimizing profit. This would be C equals 1.5x plus 2y. This would be the profit that they get from plain cookies plus the profit that they get from cookies with icing. Finally, we have our constraints. X and Y are greater than or equal to 0, meaning we can't make negative cookies. We only have enough oven space for 140 dozen cookies, so X plus Y has to be less than or equal to 140. We only have 110 pounds of cookie dough. X takes 1 pound of cookie dough per dozen, while Y takes 0.7 pounds of cookie dough per dozen. This means X plus 0.7Y is less than or equal to 110 pounds. There's only 32 pounds of icing, and cookies with icing takes 0.4 pounds of icing per dozen. So that's 0.4Y is less than or equal to 32. The last constraint is preparation time. They have a total of 15 hours for preparation time. It takes 0.1 hours for a dozen plain cookies to cook, and 0.15 hours of preparation time for cookies with icing. That's 0.1x plus 0.15y is less than or equal to 15. Alright, let's begin. So now that we have our constraints, we're going to solve for y And then after that, we're going to graph our constraints. Jordan, why don't you demonstrate solving for y?
Okay, I will do that.
Now that you have a graph, it should look something like this. Notice the quadrant 1 is the only quadrant we're using because of the constraints. Y is greater than 0, greater than or equal to 0, and x is greater than or equal to 0. When you graph the lines and then solve the system to get the intersections and to get the vertices of this feasible region, you get up here 0, 80, 30, 80, 75, 50, 110, 0, and of course 0, 0. Jordan, why don't you demonstrate our algebraic work?
Okay.
$212.50. Now, if you notice, that's the maximum, which we're trying to find. We're trying to find the maximum profit. So that's our answer. The vertices he chose were these down here. Your final step is to put this answer into a sentence answer. So Jordan, can you put this into a sentence?
Okay. Abby and Bing Wu would make the best profit if they made 75 plain cookies and 50 iced cookies, and they would make $212.50.
Now, some of you may have noticed that this line right here, x plus y is less than or equal to 140, does not affect the feasible region. This concerns the oven space. So therefore, in this problem, the oven had nothing to do with your constraints, and therefore it didn't affect your outcome. So if you figure that out, good job.